Hello, welcome back. Today we will be dealing with NATHANI's method. This method is a little bit complicated. Let my Paffin differential equation be p dx plus q dy plus r dz is equal to 0. In this method, my first step would be to choose any one variable to be a constant. Say suppose I am choosing z to be a constant. I am treating z as a constant. What will happen then is my dz will be equal to 0. Hence, the first equation will be reduced to p dx plus q dy is equal to 0. This is a Paffin differential equation in two variables. We have already seen a theorem which states that Paffin differential equation of two variables is always integrable. So definitely this Paffin differential equation is going to have a solution. Now let me name the solution as, say, phi1 of x, y, z is equal to, I have to give an integrating constant. I am giving it as c1 for the time being. Also, remember that we have treated z as a constant. So, there's a possibility for the c1 to be a function of z. I am giving it as f of z. It can be a number or it can also be a function of z as well. So, this is my second equation. This becomes my second equation. Now, the question arises is how we can choose which variable we have to treat as a constant. Always look for the question. You choose a variable to be a constant, keeping in mind that we have to integrate the reduced Paffin differential equation. Whichever variable is chosen, then the reduced Paffin differential equation should be easily integrable. So wisely choose your variable which has to be a constant. So now this is my solution for the Paffin differential equation in two variables. The next step would be, now in the next step, assign a particular value to any one variable, remaining one variable. We have already taken z into consideration. Now the two remaining variables are x and y. So assign a particular value to any of the variables x and y. Say I am treating x as a constant. Say this is equal to alpha. I am putting x is equal to alpha. As a consequence, I will be getting dx is equal to 0. My first equation will be then reduced to q dy plus r dz is equal to 0. Again a Paffin differential equation in two variables which is easily integrable. Now this would give me another solution for the same Paffin equation 1. Okay, this will be phi 2 of, I don't have an x over here, I will be having only alpha. Phi 2 of alpha y and z is equal to, say, another constant c2. Now this is my third equation. Second and third equations represent the solution for equation number 1. From 2 and 3, what we are going to do is, we haven't touched the one variable. All else has been taken into consideration. Z was treated as a constant. Alpha, x was given a particular value alpha. Now the remaining one variable is y. Now what we do is, from 2 and 3, we eliminate y. From 2 and 3, you have to eliminate y so that you get a value for f of z. Eliminate y so that you can find a value for the arbitrary function f. Okay, once you get that, the final solution can be obtained from equation number 2 as phi1 of x, y, z is equal to f of z. Whatever value you are getting for the arbitrary function f, you have to put over here. X becomes x. Wherever you have in the third equation you had alpha, you are going to forget about the whole thing about third equation because you are already used to eliminate y. Our final solution would be coming from equation number 2. That will be phi1 of x, y, z is equal to f of z. This is how you do NATHANI's method. There's no particular rule as to how to find the variable which has to be put into a constant. That solely depend upon the question as well as our intuition. Always remember that whichever variable you are going to consider to be treated as a constant, the remaining Paffin differential equation in two variables should be easily integrable. That's how you do NATHANI's method. Okay, thank you.